This episode is sponsored by Kiteworks. Federal agencies and contractors must adopt the NSA's robust zero trust data security model to combat escalating cyber threats. Kiteworks provides the comprehensive capabilities needed to reach the highest zero trust data pillar maturity levels defined by the NSA. Elevate your data security posture to meet escalating threats and stringent federal guidelines with Kiteworks.com to learn how Kiteworks can accelerate your journey to NSA's zero trust data pillar maturity. That's Kiteworks.com. Hello, everyone. This is your host, Manoj Tandon. Welcome to another episode of Dark Rhino Security Confidential. Today, we have another fantastic guest joining us. It's Jake Moshenko. For those of you who don't know Jake, he has been in the industry for a long time. He's been in the cloud native ecosystem for over 15 years. He's an innovator. He has worked at Amazon. He's worked at Google. He is the founder of Quay, which was the first private Docker registry, which has been acquired. He's also been a lead engineer at CoOS, which was acquired by Red Hat. And we're going to actually talk about some of these things. And now he's the co-founder and CEO of AuthZed, not AuthZ, a little semantic play there, but it's AuthZed. And they are commercialized in SpiceDB. So there's a lot to unpack here. Jake, thank you so much for joining us and spending an afternoon.
Of course. Thank you for having me.
And as I might want to remind you folks, this is a lot of work and we appreciate you folks listening, but we always love a little bit of love. Smash and like the subscribe button. Leave your comments below. We'll be sure to answer them. So I got to tell you, you're an entrepreneur, and that the first question is the origin story. You know, how did you go from a secure role at Google or Amazon, making, I'm sure, a significant amount of money and say, you know what, I'm going to do something insane, like quit all that and I'm going to start my own company. What happens to short circuit the mind to do that kind of thing?
Yeah, it's a sort of an interesting story. Both of my parents are actually business owners, or were business owners. My dad was a small business owner. He had a financial consulting practice. And then my mom actually owned an ice cream store. So just growing up, that was kind of very standard for me to own a business. But then they were like, you know, when I was young and they saw how I played with Legos and I was constantly building things, they're like, maybe you should be an engineer. And so I was like, all right, I'll try the whole engineer thing. So I went to school. I went to University of Michigan, got a degree in engineering, and then started down that corporate path that you were talking about earlier. Boeing was my first job, super fun, got my feet wet in, you know, the corporate world, technology, things like that. But then I moved over to Amazon and Google, which is really where I cut my teeth in cloud and distributed systems and all these things that are sort of important to what I do today. While I was at Amazon, I actually created an iPhone app, like at the very beginning of the whole iPhone ecosystem. It was a game, and I put the game into the store, and hundreds of thousands of people downloaded it. And I was like, this entrepreneurship thing is easy. Why doesn't everybody just like build a thing and throw it out there and it'll get adopted, right? Like everyone should just do that. So then kind of, you know, that entrepreneurship came back from my, you know, seeing what my parents did. It came back and re-entered my life, I'll say. And then I kind of sort of carried that entrepreneurship chip on my shoulder, that itch. I carried that with me through my other roles.
So there was never any doubt in your mind to give up a secure, what could have been a retirement role likely, and jump into the...
Of course there was doubt, right? 100%. But like the flip side, and it's kind of ironic. I don't know if you've ever heard Jeff Bezos talk about his regret minimization framework.
I have not actually.
Yeah. So his whole thing was you don't want to look back at your life and your career at the end and think about what if, right? Like, what if I had tried that thing that I really wanted to do? You know, what if I had taken that leap? What if I had gone and done that thing? You're probably more likely to regret the things that you didn't do than the things that you did do. So ironically, you know, he at the time owned one of the largest companies in the world, and he actually encouraged me to leave his organization in an indirect way, right? So
Really?
yeah, that just resonates with me that you should always be trying new things. You should always be trying to build. You should always be pushing yourself out of your comfort zone, things like that. So yes, of course, I was like, why am I leaving this very stable job at what was the time like the hottest company in tech for this lottery ticket essentially, or this chance at entrepreneurship? But looking back, it was the right move for me for sure.
That's anyone that is looking to make this kind of decision, would there be some advice you'd give to a young person that is just getting out of CMU, maybe has their job at Microsoft and is thinking, you know what, I really should?
Yeah, there's a phrase that I like to quote, and the exact numbers aren't important, but it's like 6 years later they were an overnight success, right? The way we view companies, the way we view startups, the way we view these entities is we notice them, we're first made aware of them when they're already on their hockey stick growth, right? So when you first start something, it's a grind, right? It's you just working crazy hours, working crazy hard, and it seems like it's not going anywhere. And everybody has to go through that phase, right? So if you start a business, you start entrepreneurship, and it's not immediate hockey stick growth, that's the norm, right? That's not the exception. So if that doesn't sound like it's for you, then maybe you should avoid it, entrepreneurship. But if that does sound okay to you, or you're willing to stick it out and invest in that grind, then there can be a light at the end of the tunnel.
What about failure? The fear of failure or failure. I mean, we're not, at least I can tell you personally, I have not been successful at everything I've done. That's just, and 5 companies, some went well, some went not so good. But that fear of failure, do you have any thoughts on that, or on failure in general?
Yeah. Do we fear failure, or do we fear how people perceive our failure? Right. That's one thing that you need to come to terms with. Right. Like, do I care that I failed or didn't fail, or do I care how people see that in the context of a career and career trajectory and things like that? So that'd be one thing that you'd want to ask yourself and think about. On actual failure, we've done it a ton. So when we left Google, we didn't set out to build Quay and sell that to CoreOS, right? We set out to build a web IDE. We called it DevTable. And I don't know if we were ahead of our time or behind the times, or there was no product there or whatever, but it was just an absolute slog and it never went anywhere. So that one, like, that was a failure. That was an abject failure, right? But as part of that, as part of building that, we learned and we realized this other thing that we needed, which was Quay, this private Docker registry. We had all these private Docker images and nowhere to put them. And so we said, well, hey, if we have this problem, other people have this problem too. Let's just scratch our own itch and see if we can turn that into a business. And Quay was, it was very successful, right? Like, a lot of people need it. You can still go and buy it from Red Hat today. That's how much this product was needed, and that's how much the market needed an answer to Docker Incorporated controlling this whole ecosystem. So, the failure is an opportunity to learn. And what you want to be doing is you want to be minimizing this cycle, the amount of time that it takes you to learn. So in that way, I think like fail fast is one of the best possible outcomes of an entrepreneurship journey.
Jake, those are some very, very wise words, and they come from experience. I'm glad to hear. I'm glad to hear you say it, because nobody listens to me, but hopefully they'll listen to you. That's very, very true of what you've said. And any of our audience that's listening, think about what Jake said, and if it's something that is in your DNA to do this, absolutely take the chance. The worst is never so bad, actually, from what I've seen. I mean, it can be bad, but it's never so bad. So let's talk about going to distributed systems. Well, before we get there, I'm going to ask you a couple stupid questions, and maybe you can enlighten us. When we think of Red Hat open source model, Kubernetes open source, right? How do you pay salaries on an open source system when you build off of it, utilize it, or when you're providing your technology as an open source platform?
Yeah,
How
well,
does it work?
At AuthZed, we're also open source with SpiceDB. So there's a few different business models, but the standard business models are charge for support or charge for management of the surface. Of the service. Or the third one is usually to charge for ancillary software and services, right? So first one's really obvious. You put a thing out there, people adopt it, and then they need some kind of support. A lot of times banks, for example, will require that they have a support contract from a vendor for all of the software that they bring in.
Okay.
So that one's really straightforward. That was kind of the first open source monetization strategy. Then you can take the software and you can run it as a SaaS. That's something that we do at AuthZed. We run SpiceDB as a service. And that takes the burden of running and managing the care and feeding. That takes it off of the customer and moves it onto you. And that's a thing that they're familiar with paying for, right? So I would go and have to requisition this hardware from a cloud vendor, and I would have to get SREs to manage this thing, and I would have to update it and go through the whole software lifecycle management of the service. So I might as well pay someone else to do that, right? That one's the other really standard model. And then the third model is to sell ancillary services and software. So if you have an open core, then you can decorate that with other things that make it more enticing for businesses. And then they can pay you for those things and run those in the periphery of the open core, and you can make your money that way.
There you go, folks. There's the mystery that is solved. So you guys are open source.
We are, yep.
So, and you're built on SpiceDB?
We built it. So SpiceDB is just an open source project that we created.
Okay.
AuthZed are the maintainers of that project. We build it that way so that we can build a multi-company coalition behind the idea of SpiceDB. It doesn't just have to be an AuthZed project. And in that way, sort of like how Google created Kubernetes but launched it with a multi-company coalition, right? Like that way it can become something that people can adopt without worry about vendor lock-in, things like that. We're still the primary maintainers, so that hasn't come to fruition yet, but that's sort of a rationale for why we built it and launched it the way we did.
So let's talk about the basics of a distributed architecture. Okay. So, and then we'll get into more details on what AuthZed is doing and how you guys function. But in a distributed environment, if you could do a compare and contrast to maybe a more traditional environment like an Oracle or a Microsoft SQL relational database, what's going on in a distributed database in simple terms for non-rocket scientists? What's happening?
Yeah. So the first question is why? Like, why do we create distributed systems at all? The reason we create distributed systems is because we've exceeded one of the limitations of running something on a single server, on a single box, in a single process. And those limitations, there's some really obvious ones, right? Like the CPU isn't fast enough to do all the work that we need it to do. The biggest CPUs that you can buy right now have on the order of hundreds of cores. But if you have 1,000 cores worth of work, you can't run that on even the biggest server, right? Another limitation would be memory. That's an obvious one. But other limitations that we try to work around are things like failure domains, right? So in a single server running in a single data center with a single internet connection and a single power provider, we have all these different failure domains like that, these things that could interrupt our ability to maintain our service. So if you're running out of one co-location in Newark, New Jersey, and that colo loses power, loses internet, your service is offline. So distributed systems let us exceed the capability of one box, like one particular server, as well as decouple our services uptime from all of these various overlapping failure domains of running a single box in a single server in a single data center. So that's sort of the rationale of why we do distributed systems at all. when you contrast it with something like an Oracle, like let's take Google's Spanner or Spanner likes like CockroachDB.
Okay.
When we take those and we consider them against something like a Postgres, like a single Postgres server or an Oracle SQL database, what we're really doing there, like the Oracle SQL database, its high availability comes from running an exact copy of that one box, right? So you have one box, then you have an exact copy. If you lose the primary, you flip over to the secondary and you go from there. What happens if you lose the secondary? Or what happens if they're too close together and they're in the same data center? So there's all kinds of things that can still take you out, even when you're running a quote unquote highly available single server database. So the distributed databases try to work around that, but of course there's a price to pay, right? When we're writing to a distributed database, we're usually storing multiple copies of the data. We're usually requiring that multiple different servers acknowledge that they've accepted and stored those copies of the data before they accept the write and say that the write is quote unquote committed. We're usually trying to coordinate with multiple servers in order to service a query. So if someone says, give me all the data back, right? Like give me all the rows in the database. In a traditional database, that's just a single scan through a table. But
Yep.
in a distributed database, you're potentially talking to every single node in the distributed database in order to gather all of that data and put it together and give it back to the user. Was that like a good 10,000-foot view?
That is a great 10,000 foot. And you actually used the word of the commit of the transactions. And that's something that's fairly interesting here is how does that work in a distributed model? Because like I remember, and it's been years since I have actually done work on an Oracle database, but in a high transaction space, we would wait to commit to the transactions much later in the day when there was availability, and you'd hold off, and you had really fancy transaction management going on uh, to manage that entire process. When you got a distributed environment, how do you commit those transactions immediately to something, and then how do all the other servers pick that up and synchronize themselves?
Yeah. So this is getting out of my direct field of expertise.
It's okay.
There's a couple of different papers that I would recommend if you're interested in
Right.
durable rights to distributed systems. The first one is the Dynamo paper that came out of Amazon. And
Okay.
that was basically saying if you have 7 servers and they all need to agree on something, if you can get 7, more than half, so 4 would be one more than half, right? If you can get 4 servers to say, I've received the write and I agree that this write, like I agree that this write has happened, then all you have to do now is read from 4 servers. And if they all agree, then you know that you're looking at the latest copy of the data. That's how you can get your
Ah,
consistency, right? So they call that quorum write and quorum read. You can relax the consistency requirements. So you can just do quorum writes to make sure that things are progressing on a commit timeline. But if you don't do quorum reads, like you'll get potentially stale copies of the data. The other paper that's super interesting is a paper called the Spanner paper
okay.
that came out of Google. And the Spanner paper talks about how you take these primitives, how you take essentially Paxos, right,
Yeah.
which is a distributed decision-making algorithm, how you take Paxos and you turn that into an ACID database with transactions. But fundamentally, it still relies on the same idea. There's a leader election process where those 4 out of 7 servers, for example, have to agree on who the leader is. And then the leader is the one who's coordinating all of the reads and writes, unless the leader goes away for some reason. But then as you have transactions going in, there's a weird thing that can happen. Whereas if transactions are interleaved, one transaction can
Okay.
preempt another in this distributed system. And then you need compensation mechanisms for what happens. What do you do when that happens? Right? Sometimes you can just reorder them if they're not overlapping, or if they are overlapping, you potentially have to reject them. So there's a whole bunch of very deep, very technical mechanics for how this gets done. And those 2 papers are sort of like the holy grails or the Bibles of how this
Oh, thanks for
system is
sharing
progressing.
that, because it's these. We oftentimes people we have folks that talk about these topics, and they're talking about it at a level where some of the folks don't know the foundational basics, and you just described what the basics are here, how this is working. And thanks for sure. I will try and link those up in the show notes too, those papers. And let anybody who wants to get into more of the details get into it. But that's absolutely a fascinating space. Now, do you have to have all your database on one hosting provider? So do you have to be on AWS for everything in a distributed system, or Microsoft, or whatever it is? How does?
No. So the short answer is no. You can have your data on multiple different providers. In the Dynamo example that I gave earlier, the downside to doing that is if you've got data from far-flung providers or providers that are sort of far away from a network latency or speed of light distance, you have to wait for all of those nodes to acknowledge that something happened before the system can make progress. And that takes longer, right? Like the farther away the servers are that are acknowledging things, the longer
How are
that
you
takes.
now at AuthZed? You're going to face that issue with the work that you folks are doing.
Yeah, I mean, we don't have customers who want to run in multiple cloud providers with a single database right now. From a durability perspective, they
Okay.
might want to have backups in different cloud providers, but it's not something that we're dealing with right now. But it is common to actually have under the spanner model. It is common to have your database spread out in multiple geographic regions or in multiple, at least, availability zones, and you still suffer from some of those problems. But one of the things that really helps is within a single cloud provider, they may have a single clock that they're tracking, a single version of UTC. And the closer the clocks are, and the closer that you can prove the clocks are together, the less compensation you have to do when those transactions are overlapping, right? Because one of the hard parts about distributed systems is even figuring out when things are overlapping, right? Because you can't trust the clock in the
Absolutely
computer.
not.
So this thing says it started at noon and this thing started at 12:01. Well, what if your clocks are off by 2 minutes, right? Like you don't know what order those things actually happened. So within a single cloud provider, the clocks are usually closer together than they will be across cloud
Yeah,
providers.
there's no unless you had an atomic clock coordinating every single, and everybody was referencing that. But that sounds like an expensive.
I I don't know if you're teeing me
Go
up
ahead.
or what's going on here, but the spanner paper from Google actually talks about using atomic clocks in order to set a very tight bound on how far their clocks can skew, so that they have to do as little compensation as possible in order to make sure that their database is progressing.
Yeah, and that would be an expensive solution unless, well, the U.S. Naval Observatory is handling our national time, unless they're willing to provide that service as a gratis.
Well, the hard part isn't getting time from an atomic clock, right? Like anyone can go and do that. Even like GPS. GPS is just satellites with atomic clocks in them. The hard part is how far that atomic clock is away from the call to what time is it right now that happens on the Linux kernel. So, for example, if I have a server that's running in a data center somewhere, and it did an NTP request to get the time from an atomic clock, and it was synchronized for a very short amount of time, that's fine. But if I make a syscall to get that time and I get interrupted, or if I make a syscall to get that time and my VM gets put to sleep, or there can be all kinds of things that can cause those, like even those very high quality time signals to degrade. And so then the work becomes, how do we give like a hardware path or like a guaranteed path to call and ask for the time, such that we have a high degree of confidence that the time that we think it is still the time that it is when we attach that to our transaction or
Well,
whatever.
when you guys have that sorted out, let me know, because I have no idea how that's going to take place. And I have no issue in admitting that I have no idea how that's going to work. We'll be right back after a word from our sponsor, Kiteworks. Defense contractors face immense pressure to comply with CMMC 2.0 security standards. Finding a secure, easy to use file sharing solution meeting CMMC 2 guidelines is a major challenge. The federal government and federal system integrators supporting the Department of Defense have similar compliance requirements for improving cybersecurity and data protection. Accelerate your CMMC 2.0 compliance and address federal zero trust requirements with Kiteworks Universal Secure File Sharing Platform made for defense contractors. Visit kiteworks.com to get started. But all joking aside, it's a very serious problem. Like when you're doing role-based access control, anything with RBAC, right? Latency is going to become a big deal, I would imagine, right? Because you're controlling all the identities in one place, and you might have geographically distributed users everywhere, right? And any queries to that are going to, any latency is going to, it has to flow back, or no? Am I wrong in that?
No, you're absolutely right. It's critical that authorization be fast because authorization is usually in the line of fire for every user request, right? If I go and I try to send an email, I happen to have my email open on my desktop. If I go to send an email, right, am I allowed to do that? Am I authenticated as the user, right? Like, am I sending it to a contact that I'm allowed? That's just one silly example. But if I open a document, am I allowed to make changes to it? Am I allowed to view it? So all of those things are directly just turning into latency and reduced user experience for the user if you don't have fast authorization checks. And one of the reasons that we use distributed databases to back our authorization service is so that we can have copies of that data very close to the users who are requesting that data. And we also want to make sure that we're giving a consistent view of the authorization world globally, because we don't want, like, someone revoked something on a different continent and it just hasn't trickled to us yet. We really don't want to be giving you access to something that you've already had your access revoked, right? So we try to use a highly consistent, globally distributed data store to back our authorization decisions for those reasons.
If everything is on in this kind of a distributed approach, and you mentioned like you folks don't have anyone that's really on multiple hosting providers, so the concern would be, while there may be a lot of resilience in a distributed architecture, if the underlying platform itself isn't distributed, then that becomes the weakest link and it can become a single source of failure. So there's nothing that says that Amazon can't be taken down, right? I mean, they're going to make all kinds of claims, but in theory, nothing is 100% that's hack proof. There's nothing that is totally safe. So if you take AWS out as an example, and I'm just picking on them because they're popular, not because they have anything wrong with them, it doesn't matter that you had a distributed platform.
Yeah, I mean,
right? How do you mitigate these risks, or you have any thoughts on that?
There's two parts. One is that our customers themselves are also running on AWS. So if AWS gets taken out, like their app is down, they're not super concerned with their authorization provider being up if the app itself is down. The other thing is that AWS is architected quite cleverly, right? You have individual buildings that house servers, right? Those are data centers. And then multiple data centers, right? Like physically distinct buildings. Multiple data centers are aggregated up into the idea of one availability zone. So people don't know that. Some people think that you can have multiple availability zones within a single physical building. That's not true at all, or even that they're one-to-one correlated. In AWS, an availability zone is usually multiple different physical buildings, data centers. Then on top of that, you have this concept of a region, right? So you have US East 1, for example, would be a region. And then you have US East 1, A through F. Those are your availability zones. So you have like 7 availability zones contributing to a region. You try to spread your work all around the availability zone. And then the region is geographically co-located. So let's say US East 1 is in Northern Virginia somewhere. Now you also have multiple geographic regions. So you have Northern Virginia, you have Iowa, you have Ohio, you have Northern California, you have Oregon, you have Seattle, right? So you can also spread your data and your application around into multiple geographic regions. And like that's kind of the highest level that most people worry about when they think about high availability is what if I'm in multiple geographic regions, then you can survive sort of some of these sort of disaster scenarios like an asteroid strike or a nuclear bomb or things like that. And that's kind of the highest level that you think about. But no one like literally no one can ever guarantee 100% uptime, right? Like I think
Absolutely.
you remember back, what was it, 2001 or 2002, something like that. The whole Northeast of the United States, all the way through the Midwest, lost power, right? Like
Yep.
that's one of those black swan events where you're like, okay, well, I was in Ohio and I was in New York or Newark or whatever. Like that should have been good enough, but this once in a century kind of outage happened. And when those kinds of things happen, like it's okay for us to have a little bit of downtime. Does that make sense?
It makes sense. It does make sense. And the key part is that there's no one that can guarantee 100% availability. And I think when folks are thinking about this and decision makers are thinking about these things, they should know that. The Titanic was not unsinkable,
Yeah. We usually talk about
right?
these things in terms of nines. Have you heard this term before? How many nines of availability you have? Yeah.
Yes, I
So two
have.
nines would
But
be
go
like
ahead.
99%, three nines would be 99.9, four nines would be 99.99, etc.
Yep.
Um, five nines is sort of what like the telecom industry uses to try to measure their availability. Like that's their availability target. And that's considered like a very high availability. I think it's like a few minutes of downtime per year or something like that. Um, but even they don't say
Although we
100%.
saw with the AT&T issue recently, they completely violated that.
Yeah, well, that's a different story. But like I think anybody who's out there claiming that they have 100% uptime, what you really want to be looking for are what are the things that they're going to give me when they eventually violate that. Because nobody is up 100% of the time, just period.
So let's talk about AuthZed.
Sure.
I want to make sure we get to that and dive into us. Tell us a little bit about the company and what you guys are focused on towards delivering.
Yeah, so we've talked about it a little bit already, but we're an authorization platform. So if you're building an application, let's say you're trying to build the next Facebook or the next Google Docs or the next Slack or whatever, you're building an application and you get to this part where you need to decide, can this user perform this action? Um, it sounds like a very trivial problem at first. All right, I'll just store a little bit of data in the database and say this user's admin, and then I'll write some code that says, well, admins are allowed to do X, Y, Z, alpha, beta, gamma, right? Like it seems very
Yep.
simple. But what ultimately ends up happening are you get more traffic than you were anticipating, and you end up spending a lot of time loading that data out of the database and processing it and running it through that decision-making source code. You expand geographically. And so now you've got two places where you need to make authorization decisions, and you've only got the database in one place, right? So there's where the distributed database comes from. Your users start asking for things that you never anticipated, right? Like you built the next Facebook, but then you're trying to sell Facebook to enterprises, and they have a much richer view of what authorization should look like than you
Yep.
anticipated when you first built the app. So you built something very crystallized and not very flexible, and now you're sort of stuck with it. So ultimately, what all these things sort of point to is having a separate authorization service that's very good at making these decisions, that's very flexible, that's very scalable in both the traffic and geographical and feature request along all of those dimensions. And having that external service that can make these computations for you really takes all that kind of gross security, like very risky code that you have to write. It kind of takes it all off of your plate, and you get to delegate it out to someone else who's an expert.
Now, again, a stupid question I'm going to ask here. Are you not treading onto or have overlap with a lot of the IAM vendors that are out there?
It's an interesting question. So IAM, for anybody who's listening who doesn't know what it is, IAM is identity and access management. Um, IAM as a field traditionally refers to like a company's first party employees, right? Like a company's direct
Right.
employees. I've got Jake over in accounting, and Jake is allowed to touch the spreadsheet or make these updates in QuickBooks or whatever. Um, what we're really focusing on is more of a new field, and that would be CIAM, like customer facing IAM. And
Yep.
we're not even doing the identity part at all, right? We want you to go pick your identity provider of choice. We support all of them. So we're really just focusing on customer access management. And there aren't a lot of vendors in this space yet, but certainly we have competitors, right? Like any legitimate business is going to have competitors because there's value there. There's value to be had.
Right.
So there are a few competitors there, but they're not the traditional IAM vendors that you would think of.
That's interesting because I thought the SIAM folks might overlap. So you're relying on somebody else to verify the identity.
Mm-hmm.
You're picking it up once you're saying, okay, Manoj is verified. Now, the question is, what controls does he have
Yep,
or not have
exactly.
at that point? You're once they're to you, you don't care if that's fake, legit, whatever it is. At that point, an identity provider has said this is good, so you're going to run with it. Correct.
Yeah, well, obviously, we hope that you're using an identity provider that you trust and isn't giving you fake or.
Oh, of course, but nothing's 100% as we've already discussed, and there's been umpteen cases in recent times where.
Yeah, absolutely. One of the neat things though is that you can sort of work with the controls that the IAM provider gives you. For example, sometimes they'll tell you, well, this person logged in within the last hour, or this person logged in using two-factor authentication, or this person we verified their email or not. You can use some of those attributes in your authorization decisions. So, for example, Manoj logged in with like assurance level of 1, where he just had the password, for example, might be allowed to do different things than Manoj with assurance level 5, where he did two-factor within the last minute, and all these additional things, these additional heuristics that you can bake into the identity decision. You can use those in your authorization decisions to say, you can do the admin things if you're logged in with a high level of assurance, but you can only browse around if you're logged in with a low level of assurance.
Now, at in the AuthZed environment, are you storing a lot of attribution information against the identity, or is it only against the role itself? That's it.
So
So
that, yeah,
they don't know it's me. Yeah,
that's a
we're
great question.
sorry again. We're a cybersecurity podcast,
Yeah,
so
that's a great question. We actually store everything from the resource all the way to the identity. So we don't stop at roles. Role-based access control is only one of the authorization models that you can use with AuthZed. You can also use ABAC, attribute-based access control, and it's all built on top of this thing called REBAC, relationship-based access control. So what we're actually storing are relationships. So Manoj is an admin of this organization, right? That's one relationship that we would store. And then we would interpret that relationship in order to make access control decisions. But some of the more interesting ones are, Jake is a member of the Eng team, which is a member of the employees US team, and the employees US team has view access to these policies, right? So you can build up this really interesting convoluted graph of how somebody
wow.
has access to a piece of data. And our whole game is interpreting that graph and making access control decisions based on the relationships that are there, as well as a set of rules that you've given us for how to interpret those relationships and make decisions. So we're really a very flexible, neutral platform that will help kind of apps of any shape and size add authorization to their application.
So now, as an outside idea, is it possible to actually anonymize the name but still provide the right access control? So instead of Manoj, yeah, you verify my identity is correct. Now from that point forward, I'm anonymized. So if any of the distributed servers are hacked, they don't know who is actually in that control.
Yeah, it's really funny that you asked that because I only use Manoj as an example. 100% of the time in production, what these relationships actually look like are UUID 1437628 belongs to group 734562153, right? Like it's completely unintelligible to even us as the provider of the authorization service. And it's just giving a relationship between these pseudo-anonymized or anonymized identities that exist on the identity provider or on the application side, right? Like a Google Doc, for example, has this like, 20-digit long alphanumeric identifier. And that's what you're actually getting access to. You're not giving access to a document named like the secret notes or like atomic secrets, right? So the
Right.
relationships that end up in AuthZed are universally anonymized by default.
That's very cool. And that means that as far as compliance goes, you guys are compliant all over the world automatically.
I wish it were that simple. I wish it were that simple, but it certainly gives us an extra level of assurance when it comes to like data privacy agreements and data protection acts, right? Like we don't know what we're managing necessarily, but we're still going to do, our utmost. We're still going to treat it as if it's the nuclear secrets, but the things that are actually in there are mostly useless if they leaked.
That's very interesting, and that's also really cool. I'm that's a really neat implementation of it because if you can get at the name, then now you got another critical piece of data, and now you can thinking from a hacker's perspective. Now you know who the admins are. Now you know who you want to spend money compromising.
Yeah. Well, that's a really interesting point. I don't know if you remember this thing that happened. It was a long time ago now, probably 15, 20 years. But there was a leak of all of the Verizon metadata, like all, who made
Yeah.
calls or what the area codes were, how long the calls were. And using that metadata, people could identify almost down to the individual what was actually going on, right? And so that's why, like, even though this stuff is mostly anonymized, we're still going to guard it and treat it like it's nuclear secrets because we don't want, your business's privacy and security is of the utmost importance to us. We understand that.
Right. Yeah, and you guys have built it from the ground up. So do you do you see yourself getting acquired here? I mean, I could a Microsoft, an Okta, somebody could come along and say, you know what, this is a damn good idea. All the guys who come up with the really coolest ideas are never stand alone for a very long time. So what?
Unfortunately, I don't have a crystal ball. I can't predict the future. I think if you look at venture funded startups and the outcome distribution, you could sort of assign an expected value to where we end up. But we're building this thing. We're all second time entrepreneurs. We're building this thing because we want it to be a big independent company that can sort of solve the problem regardless of whether you're a Microsoft or an Amazon customer. So I won't, I won't venture to say where we'll be in 5 or 10 years, but it's not the goal. We're not trying to build this thing to flip it.
Yeah, that is fabulous to hear. And most of the big innovators, the guys who are passionate about it aren't. They're you set out to solve a problem,
Right. Exactly.
a very real, tangible problem, and
And it's a problem that we've lived. So we know how important it is to solve application authorization in a flexible way.
what will AI do in your world?
I get this question a lot. Um, I think if you sit down and think about it from first principles, like what would you want AI to do in this world? Like you could imagine, um, let's use like a physical access control metaphor as an example, right? Like a lot of people have passcode or like key cards that they use to buzz into their apartment building or their office or
Yep.
whatever. And that's being enforced by computers and it's very precise. And if we think about what that replaced, it replaced like the front desk person or like a physical security guard. And the security guard could be fooled, right? Like somebody may have been let go, but the security guard didn't get the update, didn't know. Someone could be, we could go Mission Impossible with it and they could be wearing like a really clever mask, right? So it's like, if we think about the failure modes of AI, AI has a propensity to make things up sometimes, and we don't really want
Sure.
our access control subject to that failure mode. So I don't think we
Yeah.
want to put AI in the loop in terms of making access control decisions anytime soon. The place where I see AI giving us the ability to work faster or innovate would be in places where we can have AI, where we can double check the work that AI is doing, right? So I have some ideas for how I want my permissions model to work in my application. Maybe I can describe it to an AI and it will generate the policies and everything for me. And maybe it'll suggest
Okay.
how I could integrate that with my source code. But I can still double check those things. I can look at the policy and I can say, all right, did it make the right decision here about what an admin should be able to do? And if it didn't, I can go and as a human, I can fix it. So it's just saving me from typing and maybe helping me think in some avenues that I wouldn't have thought ahead of time. But it's not in the loop, right? I'm not taking the output of the AI and immediately using that to make decisions without double checking it. So that's sort of where I see our ability to use AI.
Uh, and I would agree with you. The human is still very much in the loop. So you're describing a scenario where, as an engine of innovation, I mean, the innovation really still stays with the human, with a thinking, conscious person. AI per se is not going to innovate for you. It can work on scenarios, but you have to come up with the scenario ideas. You have to come up with,
Yeah,
you know,
yeah. I think that's a succinct way to put it, right? Like the AI is not going to innovate for you. When the AI does start innovating for us, I think we're all going to have to go out and find new jobs because.
well, I think a lot of things. Well, now we got the Terminator story, because at that point, why does it need us?
Right, 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 right. The AI is going to be like, I don't know why I'd put a human in the loop. That just seems dangerous. They're so fallible.
Yeah.
Uh,
Yeah. There's no measuring of nines in their reliability.
right.
So,
Did you know any of them
hey,
could disappear at any moment? That's horrifying.
yeah.
Yeah,
Yeah. It's not
yeah,
reliable. The heck with them.
exactly.
So, Jake, in the last couple of minutes here, anything you want to plug? Anything you got up and coming? Want to let our listeners know about? Just floor is
Yeah, I
yours.
don't have anything. We have some talks and things that we're always doing around the internet. But without knowing the specific timing, like I don't want to plug any of them. Just check out our YouTube channel. We tend to repost things there. Our blog, if you enjoyed some of the things that we talked about with authorization or distributed systems, things like that, our blog is a great place to go and learn more about those things. Right? We have a generally very technical blog, and we're not afraid to dive into some of these issues and some of the tricky bits of what makes this problem hard and what makes it interesting to solve. So yeah, that and then other than that, if any of this stuff sounds interesting or relevant to you as a business, I'd be happy to talk about what you're doing for authorization. No strings attached. Feel free to reach out. We have a calendar on our website where you can reach out and book a meeting with us and kind of just talk about what you're doing, and we can kind of help you from a sort of neutral stance to see if there's anything we can help with or if we can point you in a different direction.
Well, that's awesome. If there's any links you want us to put in the show notes, just send them on through, and we'll make sure that those are connected up as well. Um, but this has been a very cool conversation, Jake.
Cool. I'm glad you enjoyed it.
And
I enjoyed it too.
yeah, I think our audience is going to like it. There's a lot that was discussed, and we've only just scratched the surface of what are very, very deep topics in their own individual rights of the many things that were talked about. But we're honored to have you here, Jake, and thanks for doing this.
Yeah, and thanks again for having me.
Oh, absolutely, you're welcome back anytime.